Hi class, in 15.4 we are going to be talking about histograms. So if you turn to page 1038 and take a look at problem number 1 titled Onward and Upward, let's take a look at the top. It says Minneapolis and St. Paul are known as the Twin Cities because they are close to each other in Minnesota. Both cities are home to flourishing downtowns with tall buildings. What I would like you to do to get started today is take a look at the graph shown like it asks you to do in number 1 and answer letter A with your group members. How is this graph different from the bar graphs that you have used previously? Some things that you should have noticed from this display of data is that this graph has the bars touching each other. In bar graphs, those would be separated. Also, there is no name under each bar on the horizontal axis. As you can see, there are only numbers that are marked at intervals. So those are just a couple of differences as far as what you've seen from bar graphs that we talked about earlier in chapter 15. The graph shown is a histogram. A histogram is a graphical way to display quantitative or numerical data using vertical bars. The width of a bar in a histogram represents an interval of data and is often referred to as a bin. The height of the bar indicates the frequency or the number of data values included in any given bin. Bins are represented by intervals of data instead of showing individual data values. So just make sure that you understand that a histogram, again, is another graphical way to display quantitative or numerical data using vertical bars. I think that probably the most important sentence in this paragraph is going to be the last one. Okay? The biggest difference between a bar graph that we've done already and a histogram is that we use bins instead of bars in a histogram, and we are using intervals instead of individual data values. So just make sure that that is something that you remember as far as understanding the difference between a bar graph and a histogram. What I would like you to do then with your group members is answer letter B and letter C. If you take a look at letter B, it is asking what information the histogram displays. That is the number of floors in the tallest buildings in the Twin Cities. If you take a look at letter C, it's asking if the data represented in the histogram is discrete or continuous. This is a question we've been asked a couple times now. You should have had discrete for that. And as far as explaining your reasoning, you should know that because you can only have whole number floors and buildings. I think it would be a little dangerous if you were walking in a building that only had half of a floor. So discrete data for letter C. If we turn now to page 1039 and take a look at the top number 2, it says let's think about how the bars are displayed in the histogram. With your group members, go ahead and answer A, B, and C for number 2. In looking at the answers to letters A, B, and C, letter A asked us how many bins are shown. If you referred back to the histogram on page 1038, should have came up with 5 bins. Letter B, are all the bins the same size? Yes, they are. Each one is going to represent a different range of 10 floors in those buildings. And for letter C, what does the height of each bar represent? It represents the number of buildings that correspond to the different bins of the number of floors. Let's take a look at the next part of page 1039. It says the first vertical bar on the histogram represents 8 buildings that have at least 10 floors but less than 20 floors. So make sure that you take a look over at the histogram on page 1038 to understand that statement. Now if we take a look at number 3, it says describe the range of floors included in each of the remaining bins shown on the horizontal axis. So go ahead and look at those 4 bullet points with your group members and answer those now. So in looking at the answers for each of the bullet points underneath number 3, the second bin is going to represent at least 20 floors but less than 30. The third bin at least 30 floors but less than 40. The fourth bin at least 40 floors but less than 50, and the fifth bin at least 50 floors but less than 60. and we're going to go ahead and skip number 4. If you turn to page 1040, let's take a look at number 5 up at the top. It says, Bella says, there are 5 buildings represented in the histogram since there are 5 bars. Do you agree or disagree with Bella's statement? If you do not agree with Bella, determine how many buildings are represented in the histogram. Go ahead and work on that question with your group members. Bella is incorrect in this situation. What she actually has to do is determine the height of each bar, which will indicate the frequency for that interval. Then she needs to end up adding all of those numbers together. So if you look back at the histogram, the first interval represents, or the first bin represents 8, the second one 27, the third bin 16, the fourth bin 5, and then the fifth bin 4. So if you add all of those together, you would get 60. So that would mean that there are 60 buildings that are represented in the histogram. Continuing on page 1040, go ahead and answer questions 6, 7, and 8 with your group members. Let's take a look at the answers for number 6, 7, and 8. Number 6 asks us if we can determine how many buildings have 31 floors and explain. No, I cannot tell if any buildings have 31 floors. I can only tell how many buildings have between 30 and 39 floors. The histogram does not supply the individual number of floors per building. If you move on to number 7, it asks, is it possible to determine the number of buildings that have more than 35 floors from the histogram? Why or why not? Again, it is not possible to determine the number of buildings that have more than 35 floors because the interval between 30 and 40 represent the number of buildings that have at least 30 floors but less than 40 floors. There is no way to determine exactly what values occur in this interval. And finally, for number 8, it asks, is it possible to determine the range of the data set from the histogram? Why or why not? Remember, in order to find the range, you need to take the low value from the data and subtract it from the high value in the data. So again, it is not possible to determine the range of this data set because the histogram does not give exact values, it only gives intervals. So there is no way to determine the highest and lowest data value in order to calculate the range. I think the biggest thing to understand in all 3 of these is that you have to realize no individual data is given. And like we talked about earlier, that's the biggest difference between bar graphs that we've discussed earlier and histograms that we're discussing now. If we take a look at the top of page 1041, it tells us that to create a histogram, data is usually organized into a frequency table. A frequency table is a table used to organize data according to how many times a data value occurs. The frequency table for the number of floors in the Twin Cities' 60 tallest buildings is shown. So take a look at that frequency table now, and what I would like you to do is look at number 9 underneath it. It asks you to compare the histogram to the frequency table. So how are we going to take all of the information in this table and end up labeling our histogram correctly? So those are some of the things that I want you to look at for number 9. In looking at the frequency table at the top of page 1041, here are some things that should have stood out to you then in referring back to the histogram. The x-axis that we always want to label, we've always talked about the left column of a table representing that x-axis. That would be the floor intervals. And then the frequency, which is on the right column of the table, is going to represent the height of the bars. Let's move on to problem number 2 then at the bottom of page 1041. We are building up, not spreading out. It says, did you know that New York City has over 5,800 tall buildings and is home to the Empire State Building, which is 381 meters tall? In fact, it is the 3rd tallest building in the United States. Not to be outdone, Chicago is the home to the Willis Tower, also known as the Sears Tower, which is the tallest building in the U.S. It stands an impressive 442 meters tall. So how do these big cities stack up to each other? Are there any similarities or differences in the number of floors each city's 20 tallest buildings have? Look at the table listing in each city's 20 tallest buildings. Alright, so now you are going to be put to work on page 1043. We're going to skip over number 1 and take a look at the directions underneath it. It says, to organize the data, you will make 2 frequency tables. You will then make 2 histograms to compare the different number of floors for each city's 20 tallest buildings. So in order to get started, let's take a look at number 2. It says, let's make a frequency table for New York's tallest buildings. So if you look back on page 1042, we are going to be referring to the table on the left, New York City's 20 tallest buildings. Now, in taking a look at letter A and letter B underneath number 2, to make our frequency table, the very first thing that we might want to do in looking at the table on page 1042 is put these numbers in numerical order. You will notice that they are not in numerical order as far as number of floors. That might help us figure out the least number of floors and then also figure out how to represent the intervals for the bins. So do that first and then answer letters A and B with your group members. Go ahead. After putting those numbers in numerical order, hopefully it was a little easier to answer letter A and letter B. The least number of floors in the table for New York's 20 tallest buildings was 54 for letter A. And for letter B, it says Ricky suggests having each data bin represent the intervals 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, and 100 to 110. Do you think these are appropriate? Based off of the numbers that we have, yes it is. The least data value is 54, and the greatest is 102. Letter C then down at the bottom of page 1043 asks us to complete the frequency table for the number of floors in New York's 20 tallest buildings. Make sure that you name your frequency table. So go ahead and do that with your group members. I want you to notice something very important with our little helper here over on the left. It says, remember, if a data value lies on one of the bounds, it should go in the bin to the right of that bound. So make sure that you're keeping that into consideration when you're trying to figure out the frequency as far as the number of floors go. Just for clarification, with the hint that is given over on the left, if the number of floors is 70, since that would be in one of the intervals, it would go to the one on the right. It would go in the 70 to 80 bin, not the 60 to 70 bin, because the 70 to 80 bin represents the number of floors that are at least 70 but less than 80. The 60 to 70 bin would be at least 60 but less than 70. So just want to make sure you understand the difference between that. Go ahead and fill out your frequency table. So this is what your frequency table should look like. The number of floors, 50 to 60, there are 10, 60 to 74, 70 to 85, 80 to 90, 0, 90 to 100, 0, and 100 to 110, you should have 1. I actually forgot that we needed to make sure that we named our frequency table. So you should have for your title the number of floors in New York City's 20 tallest buildings. Sorry about that. Okay, if we turn to page 1044 then, for number 3 it says, now that you have created a frequency table, let's create a histogram. Go ahead for letter A. We should know from the previous page what we will name our histogram, the number of floors in New York's 20 tallest buildings. Go ahead and create your histogram for letter B with your group members. Okay, again, like I said, for letter A, excuse me, the number of floors in New York City's 20 tallest buildings is going to be the title of our histogram. If you look at letter B then, your axes are labeled. Your x-axis is the number of floors. Your y-axis is the number of buildings. Again, those intervals represent the height of the bars, which is the number of buildings. We have for the 50 to 60 bin 10 For the 60 to 70, we have 4. For the 70 to 80, we have 5. And for the 100 to 110, we have 1. Everything based off of your frequency table.
Good morning.
Sorry about that interruption. Let's finish up today then with letter C. It says, use what you know about the distributions and patterns of a graphical display to describe what the histogram says about the number of floors in New York's 20 tallest buildings. So go ahead and answer that question with your group members. In looking at the answer to letter C then, the distribution was skewed right because there is a peak. The peak of the data is at the 50 to 60 interval. Hopefully you notice that there is also a gap in the histogram from 80 to 100. This means that many of the 20 tallest buildings in New York have 50 to 60 floors, and there's only one building that has 100 or more floors. That's it for histograms today. Please let me know if you have any questions. Thanks.